Okay, so today I'm going to go over the lesson 14 guided practice on page 134 of your instruction book. So the example says, Michelle looks at the equation negative 6x minus 30 equals 6x minus 30 and says there is no solution. Is she correct? Explain. Look at how you can show your work. Negative 6x minus 30 equals 6x minus 30. So they decided to subtract 6 on both sides to get rid of it from over here. So they're subtracting 6 on both sides, shown there. Then these 6's cancel out, these 6x's cancel out, and these two get combined to be negative 12x. And then they brought down the minus 30 and the minus 30 from the right side. And then they decided to add 30 on both sides, shown here. These cancel out to be 0. These cancel out to be 0 because negative 30 plus 30 is 0. They brought down the negative 12x, and then negative 30 plus 30 is 0, shown there. They divided both sides by negative 12 to get x by itself, and then x is equal to 0. So was Michelle correct that there was no solution? No, she was wrong because there is a solution. The solution is x equals 0. Determine whether each equation has one solution, no solution, or infinitely many solutions. Show your work. So in order to do that, we have to simplify by distributing the 5. 5 times 4 is 20. 5 times negative x is negative 5x. And then bring down the right side, negative 5x plus 20. So the variable terms, negative 5x, negative 5x, those are the same. The constant 20 and positive 20, those are the same. So when the constants and the variable terms are the same, this means that there is infinitely many solutions. Infinitely many solutions. Okay. Now the next one, gonna distribute again. Negative 5 times 4 is negative 20. Negative 5 times negative x is positive 5x. I don't know what happened here. 5x, sorry about that. Because negative 5 times negative x makes a positive. 5 times x is 5x, okay? Equals negative 5x plus 20. So here, the variable terms are different because this one's negative and this one's positive, and the constants are different because this one's negative and this one's positive. But you can see that this equation is balanced because it has the same number of variable terms. There's 5 of them even though they're negative. There's 20 constants even though they're negative, and these ones are positive. This equation looks very balanced, kind of like yesterday's lesson when they were showing the scale. So because it's balanced, we can probably assume that there is only one solution, but in order to double check that assumption, we should always simplify. So what we can do is add 5x on both sides, add 20 on both sides. These 20's cancel out. 5x plus 5x gives us 10x. These 5x's cancel out, and then 20 plus 20 is 40. So I'm just going to rewrite this over here where I have more space. 10x equals 40. We can divide by 10 on both sides. The 10's cancel out, and then we're left with x equals 4. That is one solution, right? So that would be only one solution. So we made an assumption because the equation looked balanced, but we proved it by getting the solution x equals 4. Now, because one of these has only one solution, no solutions, or infinitely many, we already used infinitely many, we already used only one, so probably this last equation is going to be no solution. But just to be sure, we're going to check. It doesn't hurt to check. So we're going to distribute this 5. 5 times 5 is 25. 5 times negative x is negative 5x, and that's going to equal negative 5x plus 20. So in this case, the variable terms are the same, but the constants are different. And as we said yesterday, when the variable terms are the same but the constants are different, that's going to mean no solution. We can check it and see if we get a true statement. So if I add 5x on both sides, negative 5x plus 5x gives me 0. Bring down the plus 20. Negative 5x plus 5x gives me 0. Bring down the 25. Okay, these zeros don't mean anything, right? 0 is just 0. It's always automatically there, but we can automatically remove it as well. So we're left with 25 equals 20, and that's not true. So if we get a false statement, something that's not true, that means it's no solution. So we proved that the no solution was correct. Okay, moving on to page 135. Let me remove my sticky note from up there. Says write a number in the box so that the equation will have the type of solution shown. So they want us to show you something that has no solution. Based on what I just said on the previous page, when the variable constants are the same, but the variable terms are the same, but the constant is different, then you have no solution. So basically, any number other than 5 would give us no solution. Any number other than 5 would give us no solution in this box. So we could put a 4 there, we could put a 3. I'm just gonna put 4 because it's the first number that came to mind. The next one says infinitely many solutions. So remember from the previous page that when the variable terms are the same and the constants are the same, then we have infinitely many solutions. That means the only choice for this box would be 5, because these have to be the same for it to be infinitely many solutions. Okay, and for it to have only one solution, the constants are the same, but the variable terms are different. Okay, so in that case, we could put anything we want in this box. I'm gonna go with 2 because it's an easy number. But literally, as long as it's different than 1/3, then it should have only one solution. And then we could solve it to check. But we don't need to because we know that rule from the previous page. What is the solution to the equation 3 times in parentheses x minus 4 equals 2 times in parentheses x minus 6? So first off, we have to simplify by using the distributive property in order to kind of get an equation that we can evaluate. So 3 times x is 3x. 3 times negative 4 is negative 12. That's equal to 2 times x, which is 2x, and 2 times negative 6, which is negative 12. Okay, now looking at this equation, we have the same constant, but the variable terms are different. So when the variable terms are different, but the constants are the same, remember that means there's only going to be one solution. So right off the bat, we can cancel out C and D, because we know that there is going to be a solution. So now we know that x is either going to be 0 or 1, because those are the only 2 choices left. We could plug those in and see if we get a true statement, or we can just simplify. I prefer simplifying to get x by itself. So I'm going to add 12 on both sides. Negative 12 plus 12, those cancel out, bring down the 2x. Negative 12 plus 12, those cancel out, bring down the 3x. I'm left with 3x equals 2x. I'm going to subtract 2x on both sides. 2x minus 2x is 0. 3x minus 2x is 1x. X equals 0. So the answer is A. Now, Brian chose D as the correct answer. How did he get that answer? There is no solution. So if we're looking at what Brian chose, if we go back to the example on the previous page, do you remember Michelle said... Michelle looks at the equation and says there is no solution. And is she correct? Well, the answer was x equals 0, just like in number 11. And Michelle said there was no solution. So both Michelle and Brian are getting confused, thinking that if x is 0, then that means there's no solution. But they're getting confused because 0 is a number. That's a solution. So we're just going to say Brian thought that if x equals 0, there is no solution. But 0 is, I'm gonna put a line through it, that's my 0, okay? But 0 is a number, so Brian was just confused. Okay? And that's it for this lesson. The assignment was to do the next pages in your practice book. Let me check what those are really quick. Pages 153 and 154 out of your practice book. Okay? Have a good day.